Welcome. This is the 8th in a series of videos demonstrating the use of two software packages, pfodDesigner and pfodApp. So today what I'd like to do is just jump straight into pfodApp. And what you see here is this is the drawing that we finished up on video 7, and I said that we were going to go ahead and show how to update bar graphs on a timer. And the only change I've made here is the colors on this fourth bar graph here on each drawing. It used to be like a purplish kind of color. I've changed it to a fuchsia. So that's the only change I've made. So we'll go over to the laptop now and take a look at the code. So here we are over at the laptop. Now before we get started, what I'd like to do is give a little better explanation of these drawings and these drawing segments. Drawing Z consists of three segments here: Z0, Z1, and Z2. Now the reason for these segments here is twofold. First of all, when the pfod device is sending information to the pfod app on your tablet or phone, you're limited to less than 1,024 bytes. So you're allowed 1,023 bytes of information transferred at any one time. So if you have a drawing like Z0 and you've got a bunch of commands in here, or a segment Z0 and a bunch of commands in there, you can have up to 1,023 bytes of data being sent. And you don't have to bother with Z1 or Z2. I like to add a Z1 and Z2 because here I'm doing three separate drawing segments, and I like to keep things itemized a bit and somewhat split up just for organizational purposes. Now, one other thing I should point out before we get going any further here is this Arduino IDE file. This is the one I use for video number 7. And everything is pretty much exactly the same as video 7, with the exception of the fuchsia, which I added here on bar number 4. It will be bar number 4 on each of the the individual drawing items, which is Z0, Z1, and Z2. So what we're going to do here is we're just going to go ahead and we're just going to update the fourth bar on each of those separate drawings. The Z0, the Z1, and the Z2, because if I tried to update all 12, it's going to be too many variables, and this video is going to run too long. So what we're going to do here, we're just going to comment out this fourth bar. And then what I'm going to do is I'm going to copy that. Up here, just below bar graph on Z0. And just below bar graph Z1, and just below bar graph on Z2. Now, in order for these items to be updated on a timer, that's the very first thing you have to do. Is I've taken it out of the function bar graph, so it's not being drawn when we call that function, but it is being drawn right after we call the function. And they have to be indexed, and this is how you do that. .idx1 .idx2 oh, I must have missed 0 again. Yep, there we go. .idx1 .idx2 .idx3. Okay, they're indexed separately, which is what they have to be in order to do the updates every 5 seconds. Now the next thing we're going to do is we're going to change the variable for the row size. So I'm just going to make this row size 1, and I want to capitalize it. We're going to make this row size 2. And we're going to make this row size 3. Now this value in here used to be 22, so what we're going to do is we're going to offset it 72.5. And that'll be offset right at the 0 point of the Y scale on the drawing. Okay, good. Now the reason we're doing it like this is we're going to have a negative value for row size. And that negative value is going to decrease as the graph moves up the screen. If you increase the row size, it's going to move vertically down the screen. If you minus the row size, like go a negative value, a greater negative value, the row size is going to increase up the screen. So we'll see how that's done here in just a second. So I've got row size 1, row size 2, row size 3. And I've got it set at 0 on the y-axis. Okay, the next thing we got to do to update these on a timer is these have to be put into updates, these 3 drawing commands. Each one from Z0, Z1, and Z2. So we're going to copy that down into drawing updates. And we're going to copy number 2. Down to drawing updates. And lastly, drawing IDX3. Okay, good. Okay, so now we're going to need those variables that we put in here, row size 1, row size 2, and row size 3. And what I've done is I had them printed up earlier just to save time. Just going to copy these up into variables where they belong. And then what we're going to do is we're going to go ahead and we're going to copy this library, Millies delay.h. We're going to put it right up there where the libraries go. Now the developer created this library, and the reason for it is anybody who's used an Uno in the past, or a Mega, your 32-bit Millies timing function, it times out after like 49 days and 17 hours, something like that. The developer's got a good explanation on his website, so I recommend that you check that out. So I think it's a good idea right off the get-go to go ahead and use a Millies delay library, because it prevents any problems from happening in the future. If you do happen to have a program that runs quite long, and into the couple of months or whatever, or several months. So that's the first thing, is I downloaded this library off of his website and unzipped it, and I've got my Millies.delay library as part of my Arduino libraries. So the next thing we got to do to go with that library is we've got to have this here, and I believe this is called an object. It's part of the class Millies delay that the developer has created. So I'm just going to go ahead and copy that up into here. Good. And then we've got this here timer.time, well, not timer.time, timer_time.start. 5,000. This is going to be the timing delay on the bar, the bar updates, the graph updates. So that's part of the dot start is part of your your Millies delay library. So I'm going to go ahead and copy that. And it says that goes in setup, so I'm going to put that in setup. Extra code goes here. Paste that in. Yep. And one other thing, we need an if statement to go with, to go with all our timing stuff there. Timing code. So I'm going to go ahead and I had this printed up earlier as well. So I'm just going to go ahead and copy it. I'm going to put it here in our loop code. Good. And I think part of the part of the library there is going to be the just finished, eh? And this is basically his code there, and this here is my code that I put in for the row size 1, 2, and 3. So that's about it. Well, there's actually one more thing. We got to come down here, and in order to go with our start time on the timer, the set time on the timer of 5 millis, well, it's 5,000 milliseconds, but that translates obviously into 5 seconds. So in order to have that work in conjunction with this here update here, what we're going to do is put 5,000 in here on the main menu. Okay, good. So what we'll do now is we'll see if this compiles, and we'll send it over to the pfod device, and then fire up the tablet, and we'll see it back at the tablet. Okay, that compiled nicely. So we'll see if it runs when we fire up the tablet. Now, I forgot to mention one thing that I should mention before we go ahead and go to the tablet. The developer on his website has got a section called Repeating Millies Delay, and then How to Write Timings and Delays in Arduino. He's named his object there LED Delay, and what I've done is I've just done up a different object here called Timer Time, and just wanted to point that out. So now we'll see you over at the tablet. Okay, we're back at the tablet, and you can see the fuchsia bar graphs updating on a timer. And I mean, that's basically how you do it. So on the next video, we're going to cover plots, and we'll see you then. Thanks.